Hello, everyone. I'm Susan Nash, and with AAPG. Really happy to be here for Pivoting 2021, Thriving with Change. We're at number 10, Imaging Technologies and Water Management for Oil and Gas, CCUS, and Energy Minerals. We have an amazing program today. Our panelists today are Brian Bohm, Apache Corporation, Kristie McLin, ConocoPhillips, Jamey Jacob, Oklahoma State University, Jim Ellis, Ellis Geospatial, Michael Campbell, I2M Consulting. We have a new technology showcase. This will be pre-recorded because it's Laura's birthday. So anyway, has a party that I made a little recording that will play. It's 8 minutes. And she's with Energy Makers Advisory Group, and she will be talking about disposal well capacity and kind of a reality check for the Permian Basin. And tonight we have our trustee leaders. We have Rick Fritz, AAPG President, Meredith Faber, DPA President, Division of Professional Affairs, and Julian Chenin, who's at the Sustainability Committee. So I'd like to take a moment to turn the platform over to our AAPG President, Rick Fritz.
All right, well, thanks, Susan. It's, yeah, you talk about change. So if you are an AAPG member or SPE member, you know by now that we are pursuing a merger between the two societies. So it's we still have a lot of work to do, but it is just a merger of equals the way it's designed, and it's a new co. So it'll be a brand new organization with a brand new name. And tonight we're going to see if y'all can name the new co. No, I'm just kidding. I'm just kidding. We won't get into that at all. We're not going to mess with the name until we don't want that argument going on. So anyhow, I see Michael laughing at that, so he'll probably come up with a good one. I just want to again thank Susan for all these. These have been great, and I appreciate I really appreciate the speakers taking their time in the evening to give these talks, and I'm looking forward to what we have tonight. So that's all I have to say. Thank you.
Great, thank you. And I'd like to turn the platform over to Meredith Faber, but also like to say thank you very much to our sponsor, Aramco Services Company. They sponsored the entire series. And I'd also like to thank Strathis, our collaboration platform sponsor. So welcome, Meredith.
Thank you, Susan. Good morning, afternoon, evening, late night to those of you around the world. I'm very happy to be here, and thank you, Susan, for the invitation. This subject is one that's near and dear to my heart as someone who used to work in the Permian Basin and constantly wrestled with the idea and the logistics of water management. So I think this is an important issue to not only go over, but to discuss the future of, just because injection wells are more for just injecting these days, and certainly water isn't the only thing that we put down them. So thanks very much for attending. And if you have any questions regarding the DPA or what we do, I'll put our contact information in the chat.
Great, thank you. So I'd also like to take a moment to share the platform with Julian Chenin, Sustainability Committee.
Thanks again, Susan, for putting this on and for inviting us. And also thank you to all the speakers. It's a really exciting lineup. As always, it's never changed. And we're really, really glad to have you here. I'm on behalf of the AAPG Sustainability Committee. And what we do is that we communicate the broad technical, economic, environmental, as well as the social benefits within the petroleum industry and sort of our collective efforts towards that space. And what better subject to talk about today than water, right? It's essentially the greater oil. It's what we need to survive as a society. And it's a key resource that us as geoscientists fundamentally understand and can relate to very closely. So we're really excited to see another engaging pivoting series tackling this subject and really the productive discussions that come out of this, because we are geoscientists, and who better understands the earth than us, right? So really look forward to it, to all of our panelists, and can't wait to learn more.
Whoops, wonderful. It wouldn't unmute me. Anyway, so our first group of panelists will be talking really specifically about water resources. And I thought we'd start with Brian Bohm of Apache Corporation, who will be kind of addressing sustainability related to water resources. So welcome, Brian.
Thank you, Susan. So I guess I may be one of the latest additions to the panel, but I guess the conversation I wanted to start is kind of a where are we going and how can we get from where we've kind of come from to where we need to be. And I think it's recognizing the fact that for a lot of the industry, we've kind of done recycling well from an EOR perspective for a lot of years. And now as hydraulic fracturing's taken off, we started to recycle our water a lot more. And we started to realize that we can really recycle a lot of our produced water in our hydraulic fracturing operations. But now, how can we go from being, I guess, the next step in sustainability? And if you start looking at sustainability, especially water initiatives, for a lot of the other industries and what they're doing is they're looking for something that they call water positive efforts. And it's taking that step from going from, hey, we can have, minimize the amount of fresh water we use to now going, we can have a positive impact on the water and the water sustainability and the water systems in which we operate. And I think there's a couple of efforts going on in that front right now. One of the things that's going on, I think, is seen in New Mexico, where the New Mexico consortium's looking at what kind of treatment options there are for produced water and how can produced water be used for kind of another industrial use or other operational use. There's even, I guess, probably one operator that's stepped beyond that group, I think, in Southwestern Energy, who's kind of had a water positive approach, or at least what I consider to be a water positive approach for a few years now with their freshwater neutral stance. And they've taken a slightly different approach in that they've gone through the effort of identifying basically remediation type projects or proactive projects they can do in the basins they operate, where they can say, hey, we work in West Virginia, there's an acid mine drainage problem in there. We can go in and we can treat this acid mine drainage, use some of that water for our completion operations, but then we have a long-term solution or fixed a long-term problem that this basin has to operate. And I think when you start looking at the other industries and what sustainability, especially on the waterfront, means, these are the type of things that a lot of companies are doing across other industries. And I think that's what hopefully is next, and hopefully what we see next for the water front in the oil and gas operation. That's kind of what I'm trying to work at as an environmental and sustainability advisor for Apache, is trying to find these water positive and water steps that we can be more water positive in our operations. So, and with that, I'll let the next group or next speaker talk and be happy to answer any questions.
Okay, great. Well, that was wonderful, Brian, and we will definitely loop back around with discussion and questions. So I'm happy to introduce our next speaker, Kristie McLin of ConocoPhillips.
Hi all. I'm currently manager of the geochemistry and basin modeling group at ConocoPhillips. So I'm not necessarily the official water management voice of ConocoPhillips. And I just wanted to make that quick disclaimer because although my company approved me being here, since it's a live recorded event, I just want to say this is me and exclusively me and my thoughts and opinions on the topic. But I've been almost in transition my entire career through different various opportunities. My first real work was in mapping geomorphology in the desert of New Mexico, and it was for the state map project. And this project was really designed to help the state understand water resources in the state of New Mexico. So I started off life, really looking in environmental fields of focus. I transitioned into geothermal industry for a little while, and I spent some time at the Energy and Geoscience Institute at the University of Utah. Then I was recruited into oil and gas, and my first role in ConocoPhillips was in reservoir characterization, reservoir quality. But shortly after I came to ConocoPhillips, I started a role in Permian water management. And I spent 3 years working water management in the Permian. And I tell people all the time, you know, I've loved each and every one of my roles in ConocoPhillips. I love the one I'm in now, but water management was the one that really was the most diverse role that I've taken. Geoscientists were involved in all aspects of water management and still are in the water management group. And so whether you're trying to preserve groundwater resources and leave those precious barrels where they belong in the ground for future generations, whether you're trying to make sure that your footprint is as minimized as possible so that you're preserving opportunity for more of the water that hits the ground to reach the groundwater aquifer. You know, reuse, as Brian mentioned, is a very important aspect of life and water management in the Permian. And disposal, making sure that if you are disposing, you're disposing responsibly, that you're able to ensure that other operations aren't hindered, other lifestyles aren't hindered. People who live out there rely on water resources, rely on surface access. And so making sure that we're good citizens of the world, good partners in the Permian Basin is very important. And in that, geologists are there everywhere. Our geologist, one of our geologists in the company is the director of water and biodiversity in our sustainable development group. And so I worked with him very extensively and then worked with him as I went into the sustainable development group following my role in water management. So I just wanted to come on and kind of tell that story and encourage geoscientists who are interested in sustainability, careers focused on water, careers focused on energy transition. You know, the oil industry has so many fantastic opportunities for you to make a difference. Your name or the name of your job does not have to have sustainability in it for you to be thinking in a sustainably minded way every day in everything you do within your job. So, you know, I can't wait to have some more conversation and answer any questions. And I really appreciate being here. And yeah, thank you very much.
Oh, thank you. That's great. Really, really appreciate it. And I think that we'll have a chance to have a really interesting conversation about where we're seeing trends right now and sort of the pressure points where we'll prioritize. And to that, we'll talk to Jim Ellis, who can talk to us about how surface images are used in water management, namely satellite. So Jim, welcome.
Thank you, Susan. Let's see. Share. Do you see it?
Yes.
Thank you. So I just want to give some examples of mapping water with remote sensing. And we'll be using these sensors, a gravity one, multi-spectral, hyperspectral, thermal infrared, radar. Then hopefully you'll be so excited you'll want to learn more about remote sensing. And so the gravity starts off with this amazing duo of systems that are up. NASA's put up the GRACE system, and they measure subtle differences in gravity. And they're able to map groundwater storage. So the map of the US you see in the lower right, it's groundwater storage as of March 29th, 2021. And the colors depict how groundwater compares to long-term records. So you can see the deficit in the Southwest is really profound, but also there's a deficit in Western Pennsylvania, and it shows up here. And we are actually, I know we're in a moderate drought here in Western New York where I live. So it's really an up-to-date map. It's not only for the US, but it also, they're providing this service around the world. So here we're looking at the Far East, and you can see the shallow groundwater storage as of March 2021. And these dark reds should only occur 2% of the time. But you can see there's some really big deficits in Southeast Asia. And so now that you have this map, you can ask, is it because of prolonged drought, or is it excessive groundwater withdrawals? So before you go out and get new acreage, I think you want to, especially if you're in an industry that requires water, you want to check these maps. And then they've evolved so that we're looking at Australia now. And the upper left is February 2009. So here's the groundwater map from 2009. A drought had just started there, but now they're coming up with the root zone and the surface map. And then in the lower right, we see the maps that are coming out as of December 2019. And you can see a tremendous increase in the deficit of groundwater, root zone, and surface water. And of course, in 2020, they had those horrendous fires because there's just no water in the system. We'll move on to multi-spectral. The USGS is using Landsat, and we're looking at a scene in the San Joaquin Valley. And so on the left side is the crop water use in 1990. So dark blue shows intense crop water use. And the right side is the same area in 2014. You can see a tremendous increase in the amount of water being used. So again, looking at these maps that are made by government agencies before you go into an area, I think is very important, and they have tremendous historical records now. You can also, there's probably billions of multispectral images on the internet and in archives. And here's a lake in Oregon. And it's just looking at what happened. This lake is about 25 miles across. And in the lower right, we have a 1984 and 1991. And in 1992, it's gone. And then by 2010, it's come back. So the changes that are going on in the Earth's surface could be very effectively tracked with these multispectral systems. And even the drones, you can put multispectral cameras on drones. And here, it's for hydropower generation, looking at a hydropower inlet that had this problem with invasive lake weeds. So they used a drone, made a very accurate map using the color infrared and the spectral bands that it collects, and then use the drone maps to guide mechanical weed harvest. So it's nuts and bolts type of work being done on the multispectral front. We'll move on to hyperspectral. Hyperspectral is interesting. It collects many more wavelength images compared to multispectral. And so we're looking on the left side at a natural color. So we've got this river coming along here, a man-made channel, and a larger river there. And the water quality indicators that can be derived: turbidity, dissolved organic carbon, and chlorophyll A from the hyperspectral. So you can see it's a more detailed level of mapping with these sensors that are also being put on drones. They're not just aircraft, but they're on drones also. And then Italy, there was an oil spill in 2010. We're looking at the Po River, a color infrared image. And they wanted to map the slick that was going down the river with hyperspectral. So this area is on the map in the smaller in this area. And so when it's yellow, they use the hyperspectral and determine that the thickness of the film was 2.5 micrometers, where it's orange. It was called a concentrate, 25 micrometers. And up here where it's over 100 micrometers, they call that the aggregate. And what's amazing is this is the Po River, and they flew the whole river and came up with this map interpreting the thickness of the film, concentrate and aggregate. We'll move on to thermal IR, and that's used for surface water temperatures. And so we're up in Idaho, and the Forest Service took an airborne system and flew up the river. And so now we're seeing on the lower right, one of the thermal infrared images. So this is wavelengths that are beyond anything you and I can see. It's energy that's emitted by the material on the Earth. And you can see the river coming down here, a tributary coming in. There's some power lines going across, and then this is a road. And so the legend is deep purple is 13 degrees centigrade all the way up to 25. The objective was to map cold water refuge for fish. And you can see the remarkable detail that the sensor's coming up with clearly mapping the refuge. It's also used for monitoring what's going on in reservoirs. So here we've got a thermal infrared mosaic of a big reservoir in California. Down here's the dam. Those cold water sinks, they let it out at the bottom of the dam. And you can see the blue arrows pointing to very cold water coming out. So it really impacts the fauna. Let me take a. And you can take the same data set and then fly up the reservoir, and you'll see these red zones in yellow. Those are warm areas that are more favorable for that unwanted algae, noxic blooms, and invasive vegetation. So monitoring monitoring your surface dam features are routine now. And Landsat also collects a thermal band. It's only done during the daytime. But here we're looking at an area that's 50 kilometers across out in the desert. And I took the thermal image and I just did a color ramp on it so that reds and yellows indicate warmer surface. I have no idea what that is. It may relate to some water in the subsurface, near the surface, no idea. Aster is another system that the USGS has up. And it has an advantage in that as it's going from the North Pole to the South Pole, it collects a daytime thermal image, but you can see it, slopes that are facing towards the sun are already heated up because it's around 10 in the morning. So it actually shows a lot of topography, but then on its return trip, as it's flying up towards the North Pole, it collects a nighttime image. And in nighttime, you don't have the effects of topography. So the arrow is pointing to a gorge in both scenes. We'll just look at this area and compare the daytime to the nighttime. So the daytime image, we've draped it on a shaded hillshade DEM. It doesn't really show anything of interest. It pretty much mimics what you see on the natural color. But the nighttime image has these very interesting dark patterns out in the flat area. Again, no idea what they relate to, but it might have something to do with water. And lastly, we'll look at radar. So the European Space Agency has radar systems that are flying. These blue and green and yellow are footprints of radar images. The data has been acquired between 2007 and 2018. And they're looking at uplift and subsidence, ground deformation. We'll just look at 4 sub areas. So in the upper left, we're looking at the Bay Area, and the blue, the legend is dark blue is subsiding. Here it's minus 2.5 millimeters a year. And then the red is uplift. And you can see the light gray is the water. So that's the ocean over here, San Francisco, Oakland. There's a lot of active tectonics in this area. But overall, around the coast, it's all sinking. When you go down to LA, they've got some major uplift here in Santa Ana, but it doesn't have as much subsidence. That's the ocean out here. But you go to Monterey, the whole area is subsiding on its own. And this area that's deep blue, that's like 5 millimeters a year it's going down. And then in San Diego, the whole area is subsiding. So that's leading to a pretty quick relative sea level rise, coastal flooding. And I suspect people that are working with water in these areas, it's got to be very difficult. Not to leave Texas out, since many of you are from Houston. Here we're looking at an image, backscatter image collected by radar. And this image shows the red areas are color coded to show inundation in standing water 5 days after Hurricane Harvey made landfall. And so they superimpose this map over the FEMA flood hazard map, the legend. And so all these areas that are yellow are supposed to be minimal flood hazard. And all the areas that are red are supposed to be the 500-year flood hazard. But there were many surprises. And the question was why? So these researchers went back And it's a little complicated, but they went back and looked at the pre-hurricane land subsidence calculated from 2007 to 2017. So in the upper left is the older data. It covers 4 years. This is the Houston area. And you see these little dark blue dots. And what they discovered with this radar is the fastest deformation was happening in distinct crater-like features with diameters less than 5 kilometers. So the maximum rate was almost 5 centimeters a year in one of these areas. So if you had a house there or facilities, that's pretty profound. And then in the last 2015 to 2017, the pattern changed and the subsidence rate increased in and near the northern limits of the city. So this changed relatively fast. Base flood level elevations and topographic gradients are modified. That's why you're getting this flood severity. And these new maps from radar are in a stark contrast to what the maps of historically have looked at of Houston. They're just, big bullseyes, but these are very high granularity. So if this gets everyone here interested in remote sensing, and you want to learn more, the late Floyd Sabins and I updated his textbook. We published it in April 2020. We're both longtime AAPG members, so it's got a geologic slant. You can rent the ebook for $15.69 from Amazon to check it out. And it's got a lot of open access downloadable data that allows you to do your own image processing. It's structured to support self-taught students. It's published by Waveland Press. And these are the chapters. There's 17 chapters. You see, we covered these 3 sensors in tonight's talk, but it also has DEMs, LIDAR, drones, renewable resources. And then finally, this is looking at the spine of the textbook. But the difference is I wrote an image processing lab manual for Envy. Envy is a very high-end image processing software. It's all free. You download it from the publisher website. But since the COVID lockdown, I said, well, there's so many people in the oil patch that use ArcGIS, companies that use it. I should do image processing lab manual for ArcGIS. So I did Pro and Desktop. And the Pro, I'll have a new YouTube channel. I'm trying to keep up with the younger generation. A YouTube channel, it will be up and running in a couple of weeks with the 12 labs, so that you can go to YouTube and learn where these different menus are in ArcGIS and do your own processing of your area of interest. So that concludes the talk on mapping water with remote sensing using these sensors. I hope many of you are getting more interested in learning about remote sensing, either on your own, your local community college, or online. Thank you.
That's wonderful. And I mean, that's a great book. I remember using the book when I took remote sensing at OU. It's a great text. At any rate, it was a different edition, obviously.
Yeah.
But at any rate, thank you. And it's a perfect segue to our next speaker, Jamey Jacob. And he's from Oklahoma State University, which will make Rick really happy. Welcome, Jamey.
Well, thank you. Sorry I joined late. I was having internet issues, but I think everyone is pretty familiar, with those problems these days. So, yeah, let me go ahead and get started. So I'm going to keep my comments brief, and I thought I'd do something a little bit different. Since we spend so much time talking about unmanned aircraft systems, I thought I'd share some stuff that we've been doing more recently. So let me share my screen here. And our big focus obviously is on using UAS for a variety of remote sensing applications. But one of the things that we've been doing is trying to do some in situ water quality sampling as well. And this is an interesting and very useful partner that works very well with using remote sensing via UAS. But in terms of augmenting the type of measurements that you get, where sometimes you're not able to get everything that you want from purely remote sensing capabilities. So most of this has been focused around utilizing hybrid UAS, USV operations. So that's the unmanned aircraft and the unmanned surface vessel. We've also been doing some subsurface stuff as well, but I won't talk about that in this presentation. And this has been something relatively new for us, primarily looking at a variety of various water quality issues related to some flood contamination, some harmful algal blooms, as well as invasive species. And so if we look at the type of stuff that we get from the airborne applications, and this just shows some samples of various things that we've surveyed over the recent years using aerial systems, including the South Canadian River, looking at endangered species in the upper left, algal blooms on Grand Lake in the lower left, and then invasive species on Lake Carl Blackwell. In particular, this is a floating plant called floating yellow heart that tends to choke out other plants within that region, and it's not endemic to North America. So it is something that spreads very rapidly, and so we've been trying to contain it within this lake. And the UAS tools provide a great resource, as was mentioned in the previous presentation, using both visible bands, which you see on the right, multispectral bands, which you see on the lower left, and then photogrammetry, which you see on the upper right. That's not that's not a picture. That's actually a 3D model that's made up of all the various images that we're able to stitch together. But what led us to needing in situ measurements were primarily both the algal bloom as well as the invasive species eradication, because both of those require that we do water quality sampling, getting a sample of the water itself, and then taking it back to the lab. And we started down the path of developing a UAS airborne system that flies, lands on the water, takes a sample, and then brings it back. But we found that to be very limiting because you only have a limited number of samples you can actually get with that system. So we needed something that could actually go in the lake and be able to take measurements directly. And some of this was driven out. I'm going to play this video real quick, which are the floods that we had here several years back. And so, this was a very serious, several days of rain that we got, that caused the banks to overflow on both our local lake, Lake Carl Blackwell, as well as Lake Boomer, which then ended up inundated Stillwater Creek as well, which again began to cause some water quality issues in a variety of industrial areas around Stillwater. And again, that precipitated a need to be able to go out and take some in situ samples as well from this. And of course, this also, again, just shows the value that you can get from plain video. If a picture is worth 1,000 words, a video is worth 1,000,000. And, samples, like this, which don't give you necessarily a lot of quantitative data that you can utilize, provide really great assessments for damage assessment and county assessors, to be able to look at the extent of flooding that you have in a region. So this data was used by Payne County and the city of Stillwater, to be able to look at the overall flood extent, and then, figure out, how best to ascertain the monetary value of the damage, as well as figure out how to mitigate, future floods, were this to happen. And this was an example of supposedly a 500-year flood. But, when you start having these, every couple of decades, you certainly have to think about how you're evaluating that 500-year, flood criteria. So this brings us then to the system that we developed, which is called Manuel. And that actually name extends from our student who was developing the system, who said that, yeah, it is designed to be on manual mode, but he spelt it Manuel, so we affectionately named it Manuel after that. And primarily, it's been assessing local lakes, Lake Carl Blackwell, Lake McMurtry, and Grand Lake, looking at water quality issues. And you can see here a sample trajectory. This is an autonomous path that it takes where the users, set out the starting point and the end point, and then we develop a grid path for the system to be able to follow. And it carries a suite of sensors on board that allow us to, measure things such as temperature. So look at the temperature variation across the lake. And this is specifically Horse Creek Cove at Grand Lake. And so we've been focused on that because that's had a history of algal blooms. And our goal is to monitor the progress of the algal blooms developing over the summer. Look at the water quality pre-bloom, during the bloom, and then post-bloom, so that we can start to look for indicators of when those blooms might actually occur. Chlorophyll is another water quality parameter that we measured because that tends to be an identifier for some of these, as well as dissolved oxygen. And you can see there's quite a variation in the different levels that you're getting based upon creeks that you're getting from the northern side here. This is the Horse Creek on the northern side of the lake, as well as the tributary you're getting off of the western side. And so you end up with these very strong discontinuities in the lake, which not only affect how the algal blooms can form and grow, where their boundaries set up, but also impacts on aquatic life within the region as well. Turbidity was one of those parameters that was actually relatively low. So I just wanted to provide this, as an example of, where things are going. We tend to be very focused on, the UAS, but there's a lot of value, in being able to actually stick your finger in the water and be able to take measurements directly from that. So hopefully we'll see where this goes. This is actually our first season for doing full measurements. So hopefully by the end of the summer and the end of the year, we'll have a much better idea about the value of being able to track these parameters over longer periods of time. We're actually just getting back out in the lake again next week. So with that, thanks for your time, and I'll turn it back over to you, Susan.
Oh, that's great. That's really interesting, and I'm just so glad that you went through the different videos as well to talk about the water quality and also just the management of the water. Interesting. So we're talking about surface water management. That's a great segue to our next speaker, Michael Campbell, who will be talking about groundwater. So welcome. Looks good. So you might unmute, Michael. So Michael, you need to unmute. We can see your screen, looks great. Just unmute.
Okay, can you hear me now?
Yes.
Okay,
Great.
fine, sorry. I'll get used to this stuff after a while. I don't want to spend much time talking about myself, except to say I've been in the business as a professional geologist and professional hydrogeologist for about 55 years now. And I've made certain observations, and I've been in about 40 litigation cases where I was an expert witness. And so I've been around the bend, let's say, and I thought when Susan asked me to make a presentation, I thought I would summarize briefly some of the salient aspects that have always been in the back of my mind. So the first is up in the upper left-hand corner, and can you see my pointer there? Upper left-hand corner, you see the classic cross-section of what groundwater is and how it occurs. And that's about as far as most geologists who've never had a hydrogeology course, that's as far as they get. They don't ever get into such things as a flow net analysis. And this is the figure right next to it in blue, where you get an idea of how the water flows in the subsurface. And then when you really get into the details, for example, in the case we did starting about 10 years ago, we used the normal 3-point solution to get a gradient on both the water table and the piezometric surface of an aquifer below. And you notice in the left-hand lower side here, the gradient's different. In fact, goes entirely different directions. Well, we then put together what's called a slab section, a flow net analysis, to try to get some idea. We did about 100 of these over the area. And we then took a good look at what the geology was. You can see in the well logs here. And we determined that this, what appeared to be sand and had always been reported as just sand, quote unquote, it is in fact fluvial lahar volcanics. That's fluvial lahar volcanics, feldspars, and a whole series. And they came down from Mount Rainier and formed the beds. And we finally did maybe 6 months of microscopy on the sediments, and you can see some of the in the lower right here, some of the plagioclase and the orthoclase and other weathering issues. Now, the reason I mention this is you get local groundwater flow, you get subsurface pressure distribution. That is the name of the game. As in oil and gas. Oil and gas is pushed along by the dynamics within the aquifer, otherwise known as the reservoir to you all oil and gas people. And if you don't have an idea of what's going on in the hydrogeology, you're losing out on a lot of issues. For example, in the early days, a fellow by the name of Toth, and then of course King Hubbard, who I was fortunate to be one of the last people that ever picked King Hubbard up for a lecture to bring to Rice University, for example, which, by the way, he had never ridden in an E-type Jaguar. I was probably the only, and probably still am, the only senior graduate student at Rice that ever drove a XKE. So he was scared to death, I got to tell you. But the fact is, he made it, and he always gave a great lecture on groundwater hydrogeology to prospective students, or to students who were going to be going in the oil and gas business. So that is an issue that has always been around. Once we did some more work, we found out that differing gradient was telling us something. And the closer we looked, the more we reckoned, well, we better look at a 20, instead of just a snapshot in time of measuring the water levels in the two aquifers. Maybe we ought to take a look at them in 24/7. So we put in from the Stevens group that we've always used over the years. They have a remote sensing system with pressure transducers that these were available even in 2013. They've gotten more sophisticated, but it still boils down to putting something down the hole, using solar to run your batteries. And what you do is you can get this on your home, on your computer in your office. And this is what, 1,500 miles away from the site. These are real-time values. This material on the right, we're looking at the lower right here of this figure. This material here is showing the battery strength, so you know what's going on there. You can see these two lines. This upper line here, the green line, that's the shallow water, and the shallow water aquifer, or the shallow aquifer. The other red line down here, that's the intermediate aquifer, where you see a lot more perturbation. And it soon became obvious that we're looking at a diurnal fluctuation. And that's why the groundwater flow was going down a few feet and then back a few feet and then down a few feet and then sliding over laterally and effectively not going anywhere, like a bathtub water that floats, that you can move around in that sort of way. But anyway, I'm trying to get to here is this interesting thing over on the right. Not only did we see diurnal fluctuation, but we also saw that the shallow peak of the diurnal was offset from the deeper peak of the diurnal, which we're putting together a paper on that. We've been working on that for a couple of years. And as soon as this particular project is over, we'll be going to press on something like that. Now, finally, let me point out that other projects we've been involved with all are more forensic involved. For example, we used to spend a lot of time looking at the Houston water supply. We did a major report on the subsidence, by the way, if you want to look it up in the literature. And one particular mud municipal utility district asked us to look at their well because their well production was falling off. And so we did sampling. That's up in the upper left-hand corner here. And we noticed some whiff of something that we weren't sure, so we decided to sample it. And here's the headspace of this particular well. You notice methane levels at about 700,000 ppm, and ethane levels a little over 200. That level on methane is explosive. We had to recommend to the municipality to shut it down because they were storing their groundwater in the big tanks with, and there was no explosion protection in their circuitry. And so they had to reconnect through other water supplies until they could install explosion resistant wiring. And that lasted for about 6 months. So if you notice in this particular graph, the ethylene's missing and the propylene's missing. Well, that's a whole nother story, but that gas is present in that aquifer here in the Houston area because of a major blowout in a site up near 1960, north of Houston, that sent water wells into the up hundreds of feet as it blew in that general area and introduced a large amount of gas into the aquifer. And it's still floating around today and will probably float around in big bubbles up on sort of being buoyed up against the shale in the top part of the aquifer. And it's probably still hanging around. The other project we did is in East Texas, where a farmer was noticing that his water was, if you put a match next to the faucet, his faucet would catch alight. And so we did a study on a natural gas well next door and took the headspace sample from the water well and compared it. And all I want to tell you about here is, if you notice, this particular natural gas that came out of East Texas here was also ethylene missing, which sort of relate us to all into the carbon-13 content of both the the farmer's well and the natural gas well. And if you notice right here, if you can see my pointer, the gas well C13 level was a little bit more than -40, whereas the headspace well was somewhere closer to 70 in terms of C13. And that sort of separated the fact that one couldn't necessarily relate it that the gas well was the cause. Once we started talking about this, the company just decided, the gas well company just decided to install new wells for the farmer, and so they don't have to spend any more money on silly things such as C13 and all that expensive data. So on that basis, let me close by saying I want to thank Susan for inviting me, and if there's any questions, I'll be glad to talk about it. Thank you.
Great. Well, thank you. That was fantastic. And what we'll do now is we have a few minutes so we can ask questions and chat. And now that we've had a chance to look at the actual technologies and the information that can be gained, I thought maybe we could circle back to talk to Brian and Kristie and see, like, for example, Brian, after looking at some of the satellite and the drone and groundwater technologies, are there any things that are like relevant to what's happening now in the industry?
Well, I think certainly some of the satellite technology would be great for operators looking at, what is the drought risk if you're looking at a new operating area. You could do the analysis ahead of time to see, is there a shallow groundwater system available? Is it an abundant shallow groundwater system, or are you in a drought prone area? Looking for surface water flows or, connections between the shallow groundwater and the surface water system, drought, or not drought, but spring type systems that would, potentially represent some kind of connection that could be a cause for concern, or something that you want to protect would certainly be another option right there. I think there's a ton of use for the spatial imagery that we could utilize. We could certainly do that in a protective, environmental, sustainable method that would allow us to do a lot of site screening and assessment ahead of our operational activity.
That's a good point. Kristie, do you have any thoughts?
Yeah, I agree. Those are all really great considerations. And I know for sure satellite imagery is something we use to monitor changes in landscape as well. And so there could be some early warning indicators, particularly for as we start going into maybe the fields of CCUS or things like that. I know there are monitoring technologies to look at changes in the ground and things that could happen if you're causing some sort of disturbance from injecting things into the ground. So there's a lot of really great I've recently seen a lot of really great technologies, satellite technologies, imaging technologies, and their uses for different energy transition roles as well as water management.
Oh, cool. Nice. So we have some questions in the chat, and I just want to encourage people to put questions in the chat. Patrick Ing says, to all panelists, is it fair to conclude that by taking good care of water use today, we won't end up living like warriors in Mad Max?
I can't guarantee anything of the sort, but I can say that, it's every one of us has to do our part, right? It's not just what we do in the industry, but what we do in our own personal lives to make sure that we are leaving water for future generations. And I know that a lot of so many things, not just in the oil industry, but even in the energy transition, like hydrogen, for example, could be extremely water intense. So it's very important that we look at the full sustainability footprint of any alternative we have in the future, particularly for water, because if we didn't have methane anymore, we'd still survive. But if we didn't have water, there's no hope. So yeah, we definitely need to keep our eye on water so we don't end up like Mad Max.
It's interesting too, because I thought of the scenario that, especially when you have transition zone oil, that if we do go to hydrogen and using like water intensive things, we may produce oil just for the produced water. It's kind of a bizarre thought.
Well, if I could add to that, Susan, I think the most important thing is that, we have good data. And, I think every industry, is, realizing more and more that all the problems are big data problems. And if we have, lots of high quality data and use that information wisely, then it tells us much more about our environment, not just the environment from the environmental perspective, but the environment around us. That's becoming a real challenge, I think, for all industries, is how you get the data, how you verify that the data you have is good, and then what you actually do with the data. Is it something actionable that you can, use to act wisely on?
Oh, that's interesting. And one of the things I thought was really remarkable, well, the way that you use the hyperspectral sensors, and also I was wondering how you might use infrared in water management. Do you use those at all, Jamey?
Well, infrared itself, since water is primarily opaque to infrared spectrum, there's not a whole lot you can use that for. However, it is really useful at picking up, things such as pollutants or vegetation, or some other contaminants that you have on the surface of the water. But it can also be really useful for picking up leaks, for example, from pipelines. Using the infrared spectrum, you can determine where you even have fairly minor leaks, because it will very readily, pick up where you have even small leaks in a pipeline, regardless of whether that's a water pipeline, an oil or gas pipeline. And those are being used right now to be able to perform routine pipeline monitoring.
That's great. Yeah, and I was really impressed with Jim, the things that you did with like being able to look at the amount of water in the soil through satellite imagery. That was interesting as well.
Yeah, the GRACE follow-on mission, it's just amazing stuff. And they're tying, people are writing papers now tying in a lot of the conflicts around the world to depleted water resources. So it's, 1 for 1. You run out of water, it's a really big problem for everybody. It's way complicated. So it's not spectral remote sensing, it's gravity. It's a different world.
Oh, right.
Yeah.
You mentioned that, exactly. Okay, so lots of questions in chat now, yay. So Julian Chenin asks, Michael, are there any aspects of hydrology that students can currently focus on in school? What other areas will be key for hydrology research in your opinion?
Yeah, I was just writing a note in the chat to respond to that, Susan. I guess my answer would be now, and has always been, come to think of it, I advise students to be one step ahead, and that means be sure and take all the water resources and the hydrogeology courses you can find while you're in school, and your resume will be considerably enhanced when you go out looking for your first job. And I get responses back to this day from in the 1990s, when it was during in the middle of one of the big oil and gas downturns. We put together a 4-month training program to cross-train oil and gas people into hydrogeology and environmental programs. We graduated somewhere around 450, I think the number was. And to this very day, I get a telephone call maybe twice, 3 times a year, although that number is dropping off now. But people saying, you know, I'm sure glad that we took that course because although I wasn't working in, well, I got let out of my oil and gas job, but I was able to get back into it. And when I came back into it with this certificate of a 4-month program, and that's Tuesdays and Thursdays, by the way, in the evenings, and then on Saturday morning for field trips. My entrance coming back in was greatly enhanced. Oh, you have this, that's good. Then that means you can do that over there. So I am convinced that the training is necessary, whether it's during school or in a program like, well, for example, the fellow from Oklahoma State, if he was around then, Wayne Pettyjohn put together the initial school. Wayne was one of my professors at Ohio State. And of course, when I saw that and how popular that was getting, I thought we'd do that in Houston, and we did it. And that lasted for about 6 years. If you look it up on our I2M page references, you'll find reference to that. And we'd have Wayne come down and give the Wayne Pettyjohn would come down and give the graduation ceremony presentation and certificates, which was always great fun. And it's too bad he's gone now.
Well, that's interesting. Well, so that's extremely useful information. I really appreciate that. So we have an interesting and intriguing question or a comment in the chat from Titus Murray. And I would like to encourage him to open his microphone and turn on his camera and discuss a little bit what you're doing in Australia.
Sorry, mute myself.
There you go.
There we go. No, I'll get it right. Hi, so I'm based in Sydney, near Sydney. So geoscientists, Australian,
Hey, Titus?
There's lots of echo.
Sorry, yeah, there's a lot of echo and the microphone sounds distorted.
Yeah. Titus, you've got some issues with your microphone. You might turn off your camera and let's see if it's just mic only.
Speak.
Titus?
How's that better?
Yes, that's much better.
Yeah,
Yay.
sorry about that. So yeah, it's really interesting. Geoscience Australia shot a lot of airborne electromagnetics and been using it specifically in groundwater. It was originally came out of minerals, but when you actually have a look at and a lot of the data is out there and available. So if somebody's looking for stuff to play with, there's a huge amount of it. There's a this report. There's a massive report they did, and a lot of this stuff, this is the Broken Hill Manage Aquifer Recharge. So a lot of it's been done to look at water for agriculture, but I'm really involved with water for coal seam gas developments. So the problem is with coal seam gas developments, do we deplete the aquifers? But the nice thing about the airborne electromagnetics is we can collect large amounts of it without going on people's land. So you don't need permission. It's originally Danish technology, a lot of it. And so it's really worth having a look at. We've found it to be really interesting in that you can actually almost get 4D. So you can fly it, then come back and fly it again. And you get some idea about how the system regenerates through wet seasons. So it's that one and the very high resolution LiDAR that's often collected with it. We can actually see the sand dunes swell after rain events. So they compact, they effectively swell with the big sand dunes getting filled full of water. So all the Australian stuff is out public domain. So if people are looking for stuff to play with, it's all there available as we download it to have a look at.
Oh, that's great. It's really helpful. Thank you for posting the link. And if you don't mind posting another link about the study that you're referring, that would be really wonderful.
Sure. And then in August, we've got a virtual conference on faults and fractures in groundwater happening in Canberra as part of the EAPG. So cross-posting, but Yeah, we're looking for people who are interested in groundwater faults and fractures. It's a big issue about recharge of the systems and how we can better characterize those. So I'll post a link to that as well.
Oh, that would be great. Yeah, thank you. So Hani El-Shahawi has a few comments and might be easier for him to make them directly. So Hani, I'd like to invite you to turn on your camera and your microphone. Maybe he doesn't want to. It's okay. So Karen Paez has a question. She said she would like to thank all the panelists for sharing your knowledge with us. Do you think fracking will become more popular around the world, or will it be replaced due to its environmental cost? That's a good question. Anybody want to tackle that one?
Well, I think, sure. I think continued oil and gas production will always side towards trying to increase recovery. So I think whether it's hydraulic fracturing or some other kind of reservoir stimulation, you're always going to have an effort to try to get more oil out of and more gas out of the reservoir. So I see it either hydraulic fracturing or some other kind of completion until we find a more efficient technology to get better recoveries to where we're, getting 80, I mean, we get what, 15% maybe at a really good reservoir recovery. Most of it's probably sub 5% recovery for, hydrocarbons. I mean, we're looking for something to get much higher efficiencies.
Mm-hmm.
Until that happens, I think you're going to see hydraulic fracturing continue.
Mm-hmm. That makes sense. So Clinton Tippett has a comment and a question for everyone. Why do we hear so much about sea level rise and so little about coastal subsidence, even though the latter could be more of a problem? ?
I might speak up on that because ConocoPhillips is one of the largest owners of coastal wetlands in the state of Louisiana, and works with Ducks Unlimited to restore coastal wetlands. And that's one of the sort of back to the comment of there's an awful lot of focus on a lot of other aspects of sustainable development, but one of the biggest protections that you have against flooding and against other types of damage would be that preservation of the coast. So I do think that is a strong focus that ConocoPhillips in particular has, and I do think it's something that is tremendously important, especially to those of us who live in areas on the coast, that we do see this flooding, we do see this hurricanes. We know how important that subsidence is, and not just coastal subsidence, but subsidence in general. I mean, I know that the state of Texas is moving away from a lot of groundwater usage to prevent subsidence and has moved more towards surface water. So I do think it is, even if it's not recognized, as broadly in the news coverage as the top headline, I do think you're right. Subsidence deserves a lot of focus.
Well, and I think that when you see some of the issues for example, in Florida, where they actually have just massive collapsed dolines and things like that, it's like it becomes really dramatic. So Alan West Nodwell has made a comment to everyone, a link that has tons of data. And Alan, would you like to open up your microphone and camera and describe exactly what that is, what the link has?
Sure. Can everybody hear me okay?
Yes, perfectly.
Great. I think when, is it Jim or James? Do you go by Jim? Was presenting? He's nodding. Yeah, whatever. Anyway, I think possibly he's tapped into these sources. But I do mapping, and I've found that there is some really interesting, so much, it's overwhelming, of the satellite reading that's going on of various things that, you know, if you're interested in, I was trying to correlate fires and the heat, which I think he was talking about too. And I have access through the Esri Living Atlas. If people use GIS and they are aware of Esri Living Atlas, there's lots of information and ArcGIS online where you can find a lot of mappable data. But the fire data and correlating it with what you see from the satellites is quite interesting. So I just wanted to mention that if you're looking for stuff to play with, that's some really, that'll just keep you entertained for endless hours.
I like your point about acres and acres of concrete not being our friends. I mean, not
Yeah.
only does nothing soak into concrete,
Oh, yeah.
they create these urban heat islands that create their own little microclimates that are not our friends.
And the maps that were shown about the changes in the flooding in the, and I live in the Woodlands, okay, so north of Houston, and we watched Harvey and all of that. But the one thing I can say is that I've lived here in this area since the early 80s, and flooding has increased over time. And I believe there's a correlation to all of the development and all the laying of concrete that we see, and it really messes with everything, you know, the drainage, you know, and the FEMA maps are, in my heart of hearts, and I heard this from somebody that works at FEMA, but those are actuarial, used for actuarial purposes. They're not really true. This is really how it is kind of maps. And so I'm really, it was good to see those inundation maps to understand, you know, that on top of that other map, that's the FEMA map, really tells a story. But boy, I really am glad I attended this. You guys, everybody that's presented, Kristie and everybody, you know, you guys, this is very valuable and it's really important. And I really feel strongly that you know, our organization should continue to emphasize this amongst our peers. Yes, it's expensive. You read this in the news. Oh, it's going to be so expensive to deal with this, but hey, guess what? It's expensive either way. Just saying.
Susan, yeah, I just would like to quickly insert something. I've added a link to a report we did a couple years ago on the subsidence issues in Houston area. And that sort of covers all the various views at the time as to the causes, aside from groundwater, but also geosynclinal, oil and gas production, and what have you. And I think we're no closer to an answer. As I suspect because they all contribute, more like Occam's razor, whatever's the simplest, and that means they all of them contribute to the issue. So.
Yeah.
That's a really good point, and thank you for sharing that. And you know, one thing too I want to point out, you know, as geologists, we study sedimentology and depositional systems. And one of the things that I found fascinating from Jamey Jacob's videos of the floodwaters. It's like, and I remember when that happened, those floodwaters, I would walk along Arkansas River thinking, oh, wow, when these subside, where are the new cut banks going to be? Where are the new point bars? I mean, understanding what exactly is happening to the topography through the depositional systems is something to think about as well. We're used to thinking about the models and then extrapolating to subsurface, and now we can go back. Okay, so here's a question from Dan Taranik. Is desalination a practical source for water?
I can maybe make a comment on that, and I would say situationally, yes, absolutely. I went on vacation once to Catalina Island in California, and that's essentially exclusively how they get their water, because even though they're in the middle of the ocean, it's a desert there. And so, sometimes it is the most practical, cost-effective way to get water, because otherwise they'd have to, I don't know, take it by boat and bring it into the island. But in some cases, maybe not. Maybe situationally, and in the case of produced water, we kind of ask this question back and forth. It's much easier for us to reuse produced water without much treatment and without going through the process of removing everything and turning it into fresh water. But maybe eventually with like lower cost renewable sources of energy and some optimal usage of some of the salts that we're removing from the water, it could become quite optimal to try things like that in the future. So situationally now, yes, maybe in the future. Yeah, I think a lot of people are coming up with some great technologies that could put us on that path.
That's
Yeah,
quite
the short
interesting.
answer, I think, from the majority of the research done is that incrementally, the closer you get to fresh water, obviously the economics work better. When you approach, and then obviously with seawater being as abundant as it is, the closer you are to seawater, it's more economic to treat seawater than it is to treat, say, oil and gas produced water. I think the question that the New Mexico research is trying to ask, and I think the bill that's proposed in Texas is trying to ask, is there's areas where there's abundant oil and gas produced water, and there's going to be an excess of that oil and gas produced water. There's also seems to be a demand or a need, at least, for some agricultural use for water, where we've got the Ogallala dewatered or, some other issues. So can it become economic to treat that water and then use it for some kind of agricultural purpose? That's going to be an interesting question to ask, because, you've already got can you offset part of the disposal costs from an oil and gas operator to do part of the treatment, and then have the agricultural use do part of the treatment, and therefore it becomes economic in a mutually beneficial manner. And that's where the economics maybe become more beneficial and the potential becomes higher. But if you're looking for a source of water, and you're, say, the city of San Angelo, it's probably cheaper to go to a brackish water aquifer and treat that than it is to take free of oil and gas water and try to treat it. It's easier to treat 10,000 to 1,500 or 15,000 TDS water than it is to try to treat free 100,000 produced water. So.
Yeah, I agree.
Yeah.
I would agree with Brian, but I think it boils down to the fact that we will have no choice. We will have to force the issue one way or another to make it economic. And if it costs more, like electricity, the more renewable we get, the higher the price is going to be, unless we can offset it with something grid-like that I won't mention in this forum, but it starts with an N. But the fact is, I agree, Brian, there's a lot of issues on the plate, but I think we'll be forced into making decisions here pretty soon. But it's going to be driven by economics, like you
Yeah,
said.
if you don't mind, Henny here, let me put my camera on. I just want to comment on what Brian and Michael just said. About 3 or 4 years ago, when I was still working with Shell, Game Changer, we looked quite closely at water treatment technologies and looked at a gamut of them and had some open calls and really looked very closely at the economic value proposition, and it just didn't work out. And I was really frustrated by that, because I think the missing link is that there has to be a role for the regulator, I felt, to sort of close the circularity loop. Because, if you just looked at the cost of the, of the water that you need to do the frack, it will never make sense by itself. And on the other hand, there was really no reward for any beneficial use of water in Texas that we could find. But I think all it takes, as Michael pointed out, is that someone needs to look a little bit at a more holistic view of things. And that someone, in my opinion, has got to be the role of state, local, or federal government. People can differ on what the role of government is, but I think that's precisely what the role of government is to look, more holistically at some of those things. I think it will come though, if electricity becomes cheap enough, nearly free, then basically you could rationalize just about any form of treatment, and make sense of it, particularly if there is some market for beneficial use. We did find some places where things made sense, but they were localized and very particular in Canada and some other places. And some of the money had to be made by scavenging, lithium and other rare earth minerals. But, that just wasn't big enough of a carrot. So
yeah, thank you. Titus Murray has pointed out that there's desalination, I guess reverse osmosis or desalination in Australia. Do you want to talk a little bit about where that is happening and how they're doing it, and economics?
Well, yeah, the economics have proved to be pretty interesting here, because it's a lot of them have sat mothballed, just not being used at different times. So we just switched ours on in the last millennial drought. So it was a $1 billion investment, Aussie, so 750 million US, and it sat there unused for nearly 10 years in care and maintenance. But it's been economic, and the biggest problem we've got is we've built on a lot of our catchment. We are having real issues with salinity, dealing with the saline discharge. So the desal plant in Perth has been running the whole time. I sent through a link. So the volumes are fairly large we're producing, and people do recognize it's bottled electricity. There's no two ways to look at it. We're basically taking electricity and then drinking it. Or the worst thing is we're spreading it on our lawns to water our lawns, which is a crazy idea. But the disposal of the brine is proving to be a real issue. So I've got a buddy who's working on one just now in a fairly remote fishing town near Adelaide, sort of 6 hours drive from Adelaide. And they're, just because of the slope, they're seeing ponding of these brines in the fishing area. So as geologists, that's a lot of what's coming from this is, how can they put tunneling in? How can they put the discharge out to it? So our experience has been good during the drought, but it's a huge amount of money, and it's a lot of greenhouse gas emissions.
Mm. Oh,
without Michael's N word.
It's good to know. Yeah, good to know. Brian, Bohm has mentioned that there's an article. Brian, you want to talk about that and what you just put in the chat?
Yeah, sure. So I believe it was last Friday, the 20th, I think. There was an article in one of the Midland Odessa papers that talked about a new project that was just being, they had a ribbon cutting ceremony for a treatment project that was looking at treatment for agricultural use. And I can't remember the two entities that were a part of it, but there was a municipal utility or one of the commercial utilities and water utilities, and then another outfit group that was working on it. And the economics they had in there was an odd number. It was $3 per gallon per 100 gallons for treatment. And I still can't put my head around that math, but it sounded like they were actually getting to the point where they said, I believe they had 95% treatment with only 5% effluent, which seemed really like an incredibly high treatment rate. Usually when you start getting into the treating high TDS produced waters, you're in a 30, 35, 40% rejection effluent rate. So it's to have something that has that high of a flow through rate would be pretty impressive. So regarding Ellen's question, I think one of the struggles with the state of Texas is you have multiple levels of sort of groundwater oversight with groundwater conservation districts. Then you have the groups of groundwater conservation districts that are supposed to be more reflective of the actual aquifer level management. And then you've got the Water Development Board that's kind of trying to manage the whole system. And the real problem, I think, is that when you try to manage it, the district level and the districts don't follow the aquifer boundaries, you can have different drawdown conditions that change drastically between a county boundary. And that completely throws everything off. On top of that, the state of Texas population growth is really narrowing into a very distinct corridor throughout the center part of the state. And that's the area where you need the most groundwater, and the most available groundwater is not in that area. So, or I guess water period. So how do you get the water from where the people are, or to where the people are from where the water is? And export permits don't seem to be a popular thing within the groundwater conservation districts. So it's a struggle.
Oh, thank you. That's quite interesting. So we have an interesting treat today. So Laura Capper of Energy Makers was not able to attend because it's her birthday and she had family obligations. So I did manage to record her yesterday. So I thought I would let us watch a snippet of her findings from the research that she did on saltwater disposal well capacity in New Mexico in the Permian Basin. It's pre-recorded, so I'll only do like a 30 or 90-second snippet, but then I'll send you a link to her, and I'll put a link here too to the full thing. I'll put a link in the chat, and I'll go ahead and share my screen, and we'll see how this works. Okay. Can you see my screen?
Nowhere near what is implied.
Sorry, Susan, we can only hear your audio. We don't see your screen.
I thought okay, I haven't clicked share. Thank you for letting me know.
Volume permit or your surface pressure utilization. You really have to check further, see what's going on in the formation. So lots of implications about how much additional produced water we can get into these wells in New Mexico. I just don't think it's as much capacity as frankly the industry really needs. So this is what is really going to push the market for recycling. You just can't continue to put it down the disposal well.
Oh, that's so insightful. And I know a lot of people will say, well, energy transition, we're going to phase out of oil and gas. Doesn't matter. But I mean, if you look at the IEA report, it's saying basically stop long-term kind of elephant hunting. Anything that's already in place is going to be utilized, and probably more so, say in the Permian Basin.
Yeah. And in New Mexico in particular, they're beautiful wells, they're attractive economically. Frankly, the only constraint we have in the area is natural resources in the terms of fresh water. And so all of our programs have got to be really pinpointed on alleviating that resource, doing something different, which we can do. So it's doable.
Right. And it's good to see that there's an incentive now to recycle and potentially reuse. What do you think is the most economic approach right now for recycling?
Oh, it's always a local dilemma. You have to optimize locally. So you've got to look, you have disposal capacity. Frankly, is there anybody else who will take the water that you swap water with if possible? And then your completion program. So it's just a day-to-day balancing act. But the good news is it's becoming very transparent what qualities of water we use. That's now public information in Mexico, whether we're fracking with fresh water or brackish water. And so there's huge ESG incentives for operators to move quickly to recycling. And really, I've spoken with each of the very largest. There are no technical barriers to using 100% produced water from frac. It might be a little more finicky or a little more complicated, but it's certainly doable, and most people are heading there very, very quickly from what I can see.
Okay, so we don't need to hear me chatter more. But I wanted to give you a snippet of this wonderful video, and I'll give everyone a link to it when we send out the recording. And I just want to, as we wrap up, oh, Christopher Green says, Christopher, would you like to make your comment with your mic and stuff?
Sure, can you hear me?
Yes.
Hi, yeah. No, it's just as a frac guy, I've been saying for a long time, you know, we're going cheaper, we're pumping bigger jobs, and we're not getting the effect. If anything, we're trying to maintain production. You know, and I'm involved with people now that we're trying to look how we can get conductivity back in and use these materials smarter. You know, there's a lot of these reservoirs where it's the strain effects on the rock. We're using a lot of fluid to get that. There must be smarter ways of doing this. And, you know, I think that's where the industry, we got to get back in the reservoir, you know, treat if we understand the reservoir, if it's been properly characterized, we can design smart treatments, and we've gone away from that.
Oh, that's a really good point. So we're out of time. This has been so good. And I just want to, oh, Ellen West Nodwell says, rock mechanics education rocks. Yes. And I want to see if Rick Fritz mentioned that he had to step away. I don't know if he's back yet. If he is, I'd like to ask him to say a few final words. If he's not, I'd like to turn the platform to Meredith to say a few final words.
Thank you, Susan. Well, this has been a very enlightening discussion on a very important topic. So I'd like to thank all these speakers for sharing your wisdom and your insight with us, and for everyone attending, and of course Aramco for sponsoring this evening. And last but not least, to Susan for putting us all in the same room together to do this exciting discussion.
Well, thank you. And thank you also for mentioning our sponsor, Aramco Services. And also I'd like to encourage people to check out our collaboration platform. And I'm typing the web address, so we'll have a challenge there and a chance to continue to share information. So thank you, and wow, see you next time. Bye.
Bye, thank you.
Thank you, everyone. Take care.
Thank you. Take care.
Thank you.
Thank you.